I think we're just about ready to get started. So good afternoon, everyone. Thank you for joining us today. And thank you very much to the Air Center for inviting me to moderate this very exciting session that we have planned for this Friday. I'm Dr. Hayley King. I'm a marine applications expert at the European Organization for the Exploitation of Meteorological Satellites, otherwise known as EUMETSAT. We're an international organization that operates satellites that observe the weather, climate, the atmosphere, and our oceans. And we do this on behalf of both our member states across Europe, with our collaborators across the African continent and worldwide, and also as part of the European Commission's Copernicus program. So it's my pleasure today to introduce our speaker, which is Professor Danielle Wood. Professor Wood serves as an assistant professor in the program in Media, Arts and Sciences and holds a joint appointment in the Department of Aeronautics and Astronautics at the Massachusetts Institute of Technology. Within the Media Lab, Professor Wood leads the Space-Enabled Research Group, which seeks to advance justice in Earth's complex systems using designs enabled by space. So fitting very well in with our reason for these networking sessions. Professor Wood is a scholar of societal development with a background that includes satellite design, earth science applications, systems engineering, and technology policy. In her research, Professor Wood applies these skills to design innovative systems that harness space technology to address development challenges all around the world. Prior to serving as faculty at MIT, Professor Wood has held positions at NASA headquarters, NASA Goddard Space Flight Center, the Aerospace Corporation, Johns Hopkins University, and the United Nations Office of Outer Space Affairs. She also studied at Massachusetts Institute of Technology, where she earned a PhD in engineering systems, aeronautics and astronautics, and technology and policy, and aerospace engineering. Professor Danielle Wood joins us today to talk particularly about the work of the Space-Enabled Research Group at the MIT Media Lab. The mission of this group is to advance justice in Earth's complex systems using designs enabled by space. The group's main message is that there are 6 types of space technology that are supporting societal needs as defined by the UN Sustainable Development Goals. And these include things like satellite Earth observation, communication and positioning, microgravity research, technology transfer, and the infrastructure related to space research and education. And I'm sure you all agree that a lot of excellent work has been done in these areas, but there's still a lot of barriers that remain that limit the applications of space technology as a tool for sustainable development, which is an interest that both myself, Danielle, and the wider Air Center community, I'm sure, share. So it's absolutely my pleasure to introduce her today, and I'm really looking forward to hearing more about all these topics, which are highly relevant to both my work and I'm sure many of yours. I'd encourage you as you go to use the Q&A function in Zoom here to ask any questions you have, and we'll come to those at the end. So Danielle, the floor is yours.
Thank you so much, Hayley. It's really an honor to do this with you today. And I look forward to our conversation later on. Thank you for the very generous introduction. It's a pleasure to greet everyone and welcome to today's Networking Fridays. I am honored to be among the speakers on the long list of really high quality speakers that have come before me. So thank you so much to the Air Center and for bringing together this idea that we who live somewhere near the Atlantic have some important things in common, that we want to ask how we can see sustainability at the level of the oceans, the air, the land, as well as in space. And we must work together because these are global and human level issues, not just for individual countries. So thank you to the Air Center for creating this dialogue. I'll just set up a moment to share my screen, present to you a brief discussion, and I'm looking forward to the conversation later on. Thank you so much to Hayley, who several times helped reiterate that the mission of my research group called Space Enabled. We're seeking to support sustainability on Earth and in space. My goal today is partly to challenge our definition of sustainability, building on the excellent work that's come before, especially provided by the United Nations as a curator for this term. But I want to highlight that sustainability, of course, it links to the environment, but also to social and economic factors, because the environment won't be sustainable unless people also are able to interact with the environment in a healthy way and have their basic needs met, while also having sustainable relationships among people groups in society. We'll be discussing that a bit as we go forward. I want to highlight that I'm representing a team, and this is the Space-Enabled Research Group as of today, along with a number of undergraduates who join us, but you're seeing here the full-time research staff members, as well as graduate students pursuing masters and PhDs in a variety of fields at MIT. So I'm so thankful for this wonderful team, and I'll be referencing some of their work and highlighting which people are working in different fields as we go. I want to always start by giving credit because the work I'll share today is really made possible by this team. As Hayley mentioned, the mission of the Space-Enabled Research Group is advancing justice in Earth's complex systems using designs enabled by space. And I hope when you hear this mission statement, you're asking yourself a few key questions. First, what do I mean by justice? And second, what does it mean for space to enable this progress toward a more sustainable future? Now, in different aspects of our work, we emphasize different pieces of the concept of justice. One piece is the idea that the world will be more just as we work toward these sustainable development goals. And of course, there are some key indicators and targets that highlight a future we need to create where we have eliminated extreme poverty, people have access to basic needs in areas like food, healthcare, and that they are able to cover access to water and the issues of gender equality addressed. More long-term, we could also say part of the concern that we have these goals is that looking back over about the last 500 years of history, especially in the creation of our modern economic system, the humanity as a group, especially those with most power, have made some decisions that have created different hierarchies in society where certain groups have great benefits and others have great disadvantages. So really a part of our definition of justice is also addressing issues like gender equality and economic equality to see what will it mean in the future for us to maintain an environment that's sustainable, addressing SDGs 13 and 14 and 15, while also reducing these power differentials that make it difficult for certain groups, actually for large numbers of people, to access opportunity for a healthy life. The Space-Enabled Research Group identifies 6 examples of space technology. Of course, this list may grow in the future. These are all areas where we can see existing benefits of using these tools for sustainable development on Earth. And we want to highlight that we want to continue to reduce the barriers, especially for groups that traditionally have not been involved with these technologies. Now, in previous research, I've shown that actually every country around the world is engaged in some way in satellite Earth observation, satellite positioning, and communications. My master's research in 2008 highlighted examples all over Africa, highlighting every single country in Africa and the ways they're involved in these 3 technologies. So of course it is global and ubiquitous, but it's also not yet reaching everyone who needs it in the way that they need it. The other side is to consider human spaceflight, as well as the knowledge we gained from microgravity research, as well as the benefits of fundamental scientific investment in research, and the idea of transferring technology from the space field to other fields. So in each of these areas, I teach a class every spring semester in our Massachusetts schedule. Every second semester of the school year, I highlight each of these 6 areas and show that there are many examples of progress, but there are also some ongoing barriers. There's also big changes actually in these fields where the technology options and the business models are changing. So if you're interested in the future, I invite you to ask me more about the class and how I highlight the key things in each of these areas that need to be changed in order to address more sustainable development. In our team, we use 6 different research methods, and of course others as needed, to ask how can we design space technology more effectively to support sustainable development goals. This includes drawing from engineering and artistic design, including artistic practice. We read heavily from social science and collaborate with social scientists, and several of the team members have that as their educational background. We also draw from complex system modeling, satellite engineering, and data science and computer science. And I'll show examples of these areas as I give my presentation today. A lot of our work is done in collaboration with people who are pursuing sustainable development work from these different levels: international organizations, national and local governments, as well as universities, nonprofits, and entrepreneurial companies. And we often are asking, how can we support their existing projects with technology from space in a fresh way that's easier, more affordable, or just less frustrating? I've been discussing this idea of sustainability, and I want to remind us again that sustainability is at multiple levels. And one area for me, my background's in aerospace engineering, and part of my goal is to remind the aerospace community to take a very integrated view. This example shows a video highlighting the temperature records that we have going back around the last 200 years and showing the gradual warming of the average temperature in centigrade as it moves forward. And as we come to the years, you're seeing the bright red, which means that the temperature at the average level up to 2018 has greatly increased given a baseline of about 200 years ago. And so we know that human activity has caused this long-term issue of, in a sense, waste heat that's creating a concern and changing weather patterns over time. It's also affecting sea level rise and creating many challenges, especially for coastal areas, but also for regions that are seeing changes in rainfall and their growth patterns for food. Meanwhile, I want to also point out that the same kind of concern we have about greenhouse gas causing global warming is also relevant in space. What I'm showing here is an example of the human objects that have been put in space. You see a ring around the geostationary belt, but you also see many satellites in low Earth orbit and medium Earth orbit. And this is also an unsustainable source of debris or waste that we have not yet decided the best way to manage going forward. And it means we have a risk in the future to ask, will we be able to continue to use satellite Earth observation, positioning, communication, to use satellites for basic science and important news services if we are concerned about possible collisions among satellites due to large amounts of space debris. Going forward, I'm showing a picture from Mars because I want to remind us that as we think about sustainability, we're actually creating new frontiers or new locations where human activity will actually threaten sustainability. I'm excited, of course, about the ideas of governments and companies and private organizations being involved with visiting places like the moon, like asteroids and Mars. But I think we should proceed with extreme caution. Here's a place where we don't yet have a lot of human waste. But of course, when we do scientific activities on Mars, we do leave behind trash. And as people are considering more ways to spend time with humans on places like the moon or on Mars, I'm concerned that we're going to take our trash with us and not bring innovative ways to manage that trash. So it's a challenge to all of us to ask, whether we're talking about Mars, where we have limited human activity, or the Earth, or the orbit around the Earth, we need to rethink how we are sustainable and also rethink who's involved making decisions about these sustainability questions. These are the kinds of questions that keep my group excited to keep doing more research. I want to mention that I talked about how part of our work comes from the practice of art. And one of our art pieces was inspired by the 1968 experience of the Apollo astronauts making an orbit around the moon and looking back at the Earth. This is a famous image provided by a NASA astronaut that comes and shows us how the Earth looks if you're actually flying over the moon. And it really is an iconic way that reminded people back in 1968 to really consider the Earth as a system that's so valuable and fragile. And it's one of the activities that was happening around the time that movements were happening to really bring environmentalism into a formal government activity in the United States. And organizations like the Environmental Protection Agency were being developed and advancing environmental protection activities. Our team was inspired as we celebrated the 50th anniversary of the Apollo moon landing last year. And we created this concept of what if we could take more people to the moon, at least virtually, so they could experience this idea of looking back at the Earth and reflecting on the fragility of the Earth. And I want to give credit to several colleagues in my team that have moved on, but this is the work of Elizabeth Barrios de la Torre, Rachel Peterson. And we took great inspiration from author Frank White, who wrote the book that many people have referenced with this idea of the overview effect, the idea that we often, as we look back at the Earth from space, get a sense of concern for the environment. Our team was able to collaborate with the Intrepid Museum of Sea, Earth, and Space. And during the celebration of the 50th anniversary of the Apollo last July, we were able to set up a display, and we created this environment where there actually was a bench and people could sit and look at this projection that, as if they were looking at the Earth in the distance. And we asked people, often families with children, to sit for a few minutes in the dark and look up at this Earth, which was a projection of satellite data coming from the Discover and Epic camera, which gives us a view of the whole Earth on one side. And they could ask the question, if you could see the Earth from this vantage point, imagine yourself there, and how would you reflect differently on issues of climate and the fragility of our planet? So we hope we gave people a little bit of the overview effect that day. It remains to be seen, but we had about 400 people go through the event that day. I'll highlight a few examples of the research in Space Enabled, and it highlights 3 themes. I'll show examples of our work to design systems to make space both more accessible and sustainable. And sustainable here means we hope to make it useful and safe to use for years to come. The second theme gives examples of space technology being used to support sustainable development. And the third theme talks about the links between technology and justice. So I'll give a few examples going forward. In this first area, we'll discuss designing systems that make space both accessible and sustainable. The first activity directly addresses this topic of the kind of debris and waste. And of course, you may feel like your work may not directly relate to this issue of space debris, but I want to highlight that all of us are users of services from satellites. In our daily life, we're depending often on whether it's positioning information that helps us find our way around as we navigate, or whether it's satellite communication for television connection, or whether it's Earth observation, as we mentioned from EUMETSAT, providing us information about weather. So all of us need to be stakeholders to say, we must ensure that it's safe to keep operating weather and communication and other kinds of satellites, because if we don't do that, we won't have these important services. So in honor of this, and because there's a lot of excitement about putting new satellites in space, we're working with the World Economic Forum, which has proposed a system called the Space Sustainability Rating. We're also collaborating with the European Space Agency, the University of Texas at Austin, and a company called Bryce Space and Technology. Together, we're creating this system to basically ask people who are operating new satellite missions in space to do everything they can so that their particular mission is reducing as much as possible the space debris they create and reducing the risk of colliding with other objects in space. It's really quite challenging for any group to understand all the objects that are in space. We don't have a full picture. We have models that are really high quality, but we don't have a full picture of all the objects. And there's a concern that some pieces that are orbiting the Earth are really trash, that are not controllable. We can't move them easily. They're just floating and orbiting in a certain path, but we can't necessarily move them as desired. So if one of those objects is threatening a satellite, that satellite has to figure out what to do to move. The space sustainability rating, it follows models of other sustainability ratings you might see on Earth contexts, such as those that encourage building operators to be as green as possible. And so we're going to follow that same model and give rewards based on a list of activities and decisions that operators of space missions can use. They can choose this when they're designing the actual satellite. They can choose it during their orbital time, and considering how they share data about where their satellite is with other operators, and things that they do to help avoid collisions between their satellites and other objects. And they also make a decision about how to end the mission and what to do with the satellite when they're finished using it. And ideally, they put it into a safe place, either back toward the atmosphere for destruction or into a safer, less popular orbit. So all of these actions can help them get a high space sustainability rating. And then they can brag about all the good things they've done to reduce space debris and be more sustainable in space. This work is really inspired by the work of the United Nations Committee on the Peaceful Use of Outer Space, which over the last decade has developed a series of guidelines that help support the long-term sustainability of space, published in 2019. And this is really an excellent moment of consensus where many countries, about 90 countries, agreed on these are the activities that will really be important to lay a foundation for sustainability in space in the future. So we take a lot of inspiration from that activity. Another question to think about the future is, will we need in the future a space traffic management system similar to what we've seen right now? Of course, globally, there's an air traffic management system. So many planes travel around the world safely because there's a lot of coordination across countries. We don't have that same kind of coordination in space right now. We think we'll need something like that eventually in the next few decades. One of the questions our team had was, what is the concern of new companies and new countries in designing this eventual system for space traffic management? My colleague Miles Lifson has just completed his master's research on this, and we draw from the definition of the International Academy of Astronautics, highlighting that if you had a space traffic management system, you'd be able to promote safe access into space and ensure that as different organizations operate their satellites, they're able to move safely through space and plan routes that are effective and allow everyone to be free from interference. So Miles interviewed a number of people, about 15 people from different countries. We wanted to ask people from countries that have less experience in space, but are very active in space now, and they're developing their space activities, and they expect to do more in the future. So you see the list of countries from Africa, Asia, parts of Central and South America, and from Europe. The idea was to ask them what are their concerns about how a future space traffic management system is designed. And we thought it was very important to account so that there's a global perspective on what kind of design should be there. Here's just one example of the results. We think this is a very unique data set showing the perspective of countries that are going to help shape the future management system that should be international. And it must include points of view from all parts of the world. One more example on the idea of keeping space more sustainable is asking what technology is needed that's affordable and also sustainable in the Earth sense in order to help remove satellites from space after they're finished. So we would like to explore the use of candle wax and beeswax as fuel for smaller satellites, especially if all you need is to remove them basically from orbiting the Earth back toward the atmosphere to be destroyed safely. And this is one way to reduce space debris. And I want to mention Dr. Javier Stober and his team who've been doing this research as a hardware development process. So we're particularly asking the question, this is your basic standard candle wax, but actually it comes often from a process that's not sustainable, such as the refining of oil products. So we're actually very interested in also in exploring further the use of beeswax as a fuel system for satellites. First, we want to understand, we're drawing from traditional research that's been done over the last 20 years, showing that it is indeed possible to burn wax, and you can get enough fuel for a rocket that way. You mix it with an oxidizer like oxygen. But we want to see if this can be done also in different locations, basically in our laboratory, but also in a vacuum chamber. That's more like how it would be in space, on the International Space Station, where you have microgravity, so the effect of gravity would be different, and also on a satellite itself. So we're taking step-by-step processes to do different experiments. We want to study how the convection, the natural convection, the forced convection would be different. We need to study the thermodynamics and also the temperature changes in great detail. So we're doing experiments like this in our laboratory. And of course, we've had some break due to the COVID pandemic, but we were looking forward to getting back into this work. And we're basically watching this process because it's very exciting. What you're seeing here is liquid wax spinning. And it may seem like a bizarre thing, but we're trying to show that you could actually easily manufacture just the right shape to turn this wax into fuel for satellites. And it should be able to be done in an affordable way that's low cost and might even be doable in space itself. That last piece just showed we get this really great shape, which is a cylinder with an empty hole in the middle, which is just right for burning the wax for fuel. We've been doing experiments in the past, sending our students actually to fly on planes that make this unique shape in the sky. And as they go over the top of this hill, or kind of make this shape as if they're on a roller coaster on the plane, it allows the students to experience microgravity. This is Juliet Wanyeri, who's originally from Kenya, and is a mechanical engineer, just completed a dual master's degree at MIT. And she's flying alongside an astronaut, Katie Coleman, who's retired from NASA, and she's actually executing our experiment. And I'll show you what she's doing. She's making the wax spin, and we're trying to find out if we get the same results in microgravity, kind of like space, as you would on Earth, to get this just the right shape with this analog representing the wax. And we think it is possible. We want to do more experiments of the same kind. All of this is part of technology development to help make it easier to remove satellites after they're finished with their mission in space, make room for the next generation. Okay, so those are all examples of our work, highlighting our inventions and our policy recommendations to make space itself both more accessible and sustainable. Let's move a bit back down to Earth and talk about using space technology to support sustainable development, especially for communities and governments that have local goals to change things in their own society. I'm thankful because I'm often invited to collaborate with people around the world. And you'll see examples here of research done by Neil Gaikwad, Fatima Muniafa, Ufomo Owemira, Jack Reed, and Seamus Lombardo. And each of them are doctoral students who are looking at this topic, and they're designing approaches to improve the way that we can use data from satellites in highly relevant techniques for those who may not traditionally use satellite data, people from farms, people who live in indigenous communities and forest, people who are interested in using this data to host low-income communities near mangroves or in other wetland areas. We want to make this kind of data very accessible no matter where people are from. Just drawing from the NASA example, I'm a NASA alum, but of course, with the full appreciation of the European team and Hayley's work, both with EUMETSAT and the broader Copernicus program, we're so thankful for all the open source scientific data that's available. People often think of satellite data and they talk about, well, there's certainly a lot of imagery and it's great. We have, of course, the Landsat system and the Sentinel systems from the US and from Europe. And of course, those are wonderful pictures basically of the Earth from space. But people often neglect the fact that there are a number of other satellites that are taking measurements. And they don't create pictures per se, they create data sets, such as looking at wind speeds, so the Cygnus mission that you're seeing now, or soil moisture, or understanding the pollutants in the atmosphere. And basically, we have a combination of satellites between the United States and Europe and Japan and India and China and countries all around the world that make measurements of every aspect of the environment, thinking about the ice and its changing at the poles, thinking about the ocean and its state, looking at the winds in the atmosphere, and understanding what's happening on land for biodiversity. This rich data set is very powerful. We can do things like combine data from a variety of satellites. And this is a combination of data that is actually a wonderful collaboration across multiple countries, across multiple continents. And basically there's a daily update highlighting rainfall from the last 6 hours. And you can go online and look for this. It's called the iMerge data set, and it's available regularly to see a visualization of global rainfall. And many satellites have combined to make this data. Another example is looking at understanding the health of vegetation, including crops, by understanding the level of chlorophyll, both on land and also in the ocean. And this kind of information is available at global scale, but also local scale, if we look at different types of satellites. All of this data informs issues around how to address some of the key SDGs. But in order to make it useful, we have to go from just having satellite data to actually have information for decision-making. So my team has this idea, we call it the Environment Vulnerability Decision Technology Model, or EVDT. The environmental model really draws heavily from what I just showed. We want to pull in data, both from satellites, but also from aerial observation, like drones, from ground-based measurements, like air pollution sensors. And we can use that to create estimates of what's happening in the environment. What's the temperature, what's happening with rainfall, what's happening with soil moisture, what's happening with air pollution. All of those features affect people's daily lives. There may be some human vulnerability or benefits. There may be some social impact, especially if there's issues due to storms or other kind of major disasters like earthquakes. So we also want to be able to have the right parameters to estimate what's happening for people on the income in terms of access to housing and transportation infrastructure. We should also then estimate what kind of decisions governments are making. How are they making responses, either during times of disaster or during times of ongoing management of the environment? And finally, we can ask the question, do the decision makers have the information they need to make the best decisions? Do we need to invest in new sensors? Do they need different satellite data, different aerial data, different ground-based sensors? So our model here asks the question, what's happening in the environment? How's it affecting humans? What policies should respond? And also, is there a need for investment in new technology? We try to apply this whenever we're working around the world on different projects. And recently, actually, it's been interesting to take this same framework and add one more piece, because of course, during the global pandemic, we're also interested in the question, how are all these features related to COVID? So we've created this thing called the VITA, Decision Support System, which takes all that I just showed you and adds a public health model. We've been collaborating with colleagues, especially coming from Harvard and East Carolina University, in the firm called Blue Raster. We've developed a dialogue with leaders who are making decisions on COVID policy, especially in the countries of Brazil, Chile, Mexico, and Indonesia. And we've had a chance to ask them, how are you using different kinds of data to inform the next steps as different cities are making policy to open or close things during COVID? And they are indeed using data from public health indicators and trying to use dashboards that kind of highlight key features. But it can be challenging to combine that public health data with data about the environment, how are things changing during times of closing or opening, and with data about socioeconomic changes such as housing and employment. So our goal is to make an integrated framework that allows organizations, especially that are advising governments, so they can think about when to open and close and how to provide social safety nets, such as perhaps financial incentives to help businesses and organizations and people during times of closing. So the VITA Decision Support System has been gaining progress, and we now have prototype models that highlight how to organize a visualization of the public health status during COVID, but also considerations of the environment and socioeconomic outcomes during policy changes as well. Here's just one example highlighting things we can show. It's basically showing some of the environmental measurements that we can draw from in the city of Rio de Janeiro. So on the right side, you're seeing a geographic summary of the level of pollutants. In this case, it's showing particulate matter, what's called PM10. And you're also seeing a historical graph. And basically, if you're able to interact with this website, it gives you different examples, and you can open different views and see public health data as well, or environmental data, or socioeconomic data. We're continuing to improve the interface to make it easier to compare what's happening at different parts of the history of the city, and also to make projections about the future. Let me highlight an example of work we're doing in Benin and Ghana, supported by a grant from NASA's Applied Sciences Program. And this work brings together several organizations, 2 government organizations in Ghana, as well as teams in Benin, both public and private. And we're also collaborating with a team from NASA and the company Blue Raster. It allows us to ask, how can we best use SDG 15 as a guide to support sustainable development, looking at forest management in both Benin and Ghana? And I'll highlight briefly some work focused on the area of Lake Nokwe, which is a key region, especially near the city of Cotonou. And it's one of the big cities in Benin, just in the Atlantic coast of Western Africa. And in this area, you'll see in this aerial view, homes and boats for a community that lives highly on the water. And people who live in this region depend heavily on the water for transport, as well as for economic activity. Now, there's a concern because in this region, like in many countries around the world, there's been an invasion of this particular plant called water hyacinth. And thinking about the Atlantic community, this is a case where the Atlantic is shared from one side to the other. And actually, this is something that belonged more so in the Amazonian region, but it's been moved by humans to other regions. And it's actually active in 80 countries now. But it's not one of the positive examples of sharing, because the plant can often grow and really outgrow local plants. And it can cause this kind of blockage where it's difficult for human power boats to move around. It's a seasonal plant, and the company called Greenkeeper Africa sees it as a possible benefit financially. They work with local community members to harvest the plant, and they convert it into a product. What you're seeing here is the chopped up, dried water hyacinth, which has great properties. It can actually absorb oil-based pollution. So in fact, they're interested in helping around the world, but especially in local areas where there's industries and vehicles that create oil spills, and they're looking at the opportunity to help clean them up. And so they sell this commercially. But they're also interested in the question of how they can build companies and jobs in the area. And they're able to train local people in entrepreneurship and support some of the micro enterprises also building off of the same product. I met the team in 2017, and since then we've been working on the idea of creating an observatory using data from satellites, from aerial observation, and from measurement tools that are based in the water. And it's their first time to try to create geospatial tools to help them track where the water hyacinth is growing. And this example shows a map with giving 1 month, and we're using data from Landsat in this case, but we're also using data from Europe, such as Sentinel, to validate the Landsat analysis. And we're also comparing it to commercial data sets. Our goal is to identify the best estimate of where the water hyacinth plant is changing, and we can create historical summaries as well. So what you see here is a long 20-year record highlighting the level of surface area of the lake that was covered by water hyacinth in the different years. And all this is compared to the local experiences by the teams. So we're doing this at the invitation of the local company, and we're collaborating with local scientists at the local universities, as well as government teams who've also been studying this lake for many years and can help us validate this information. The team has also been experimenting with the use of drones. And what you're seeing here is a drone image on the right-hand side of a particular practice, which is the use of local tree materials to create fishing ponds, which is one of the traditional techniques to increase fishing yields. It has a complex link because you see a combination of an opportunity to increase fishing yields, but also challenges in terms of keeping the lake healthy and the fact that you are also creating new sediment and other kinds of sort of pollution into the lake. Eventually, we'll be working with the team locally to use an online dashboard that summarizes the data we're collecting from satellites, from drones, as well as from in-situ water collection. And this kind of tool will be a first opportunity for this company to really share publicly environmental data that they're creating alongside local scientists. So we're excited to see how this can help with both planning as well as monitoring the progress for the company. Also in Ghana, I want to highlight an example. I'm visiting here the Ghana Space Science and Technology Institute, and they have researchers who are interested in using satellite data, especially looking at the issue of illegal mining. In parts of Ghana, there are opportunities to do really interesting gold mining, and there's a local National Environmental Protection Agency that provides standards for how gold mining should be done safely. But there is a growing concern about illegal or not correctly done gold mining that doesn't follow local standards and might even involve using sort of large-scale equipment in ways that are not allowed normally. And often it's done in areas near rivers. There's a desire to have water access, and you have a concern that there's pollution into the water due to the chemicals such as mercury that are being used to isolate the gold. So our team is working with a collaboration with a colleague from NASA Goddard Space Flight Center, and we've been working on mapping the areas that have been converted from either water and they've been converted into mines, but also from forests that have been cut down as part of this mining exercise. And again, we're drawing from the capabilities of data such as Landsat and Sentinel. We're also benefiting from Google Earth Engine, which is a tool that allows the team to quickly organize large data sets based on this cloud-based data processing rather than downloading the satellite images down to our own computers. So it's easier to do long-term data analysis, such as this measurement from 2008 until today, understanding for each year how much land has been converted into mining or into urban areas. Then we can compare to local experiences and consider how the local team has also been doing similar analysis. So there does seem to be an increase in the amount of area converted into mining in this area of Ghana. We've also been able to then identify exactly which areas were affected each country and each year. So here's is showing the same area in Ghana, and what you're seeing is the colors represent which year the area was converted from forest into mining. So it gives a sense for how things are spreading out from starting near the river into areas near alongside. And what you're seeing on the left side is an example of the tool we use for data validation. And it's a process we're doing to estimate the amount of error that's in the analysis so we can better give the responses to our local partners. I want to make sure we have time for discussion, and I have a few more examples to share, but I'll just give one more example and then pause because I want to make sure we have time for Q&A. And of course, if there's an opportunity, I can continue to show examples from my slides. This is work by Jack Reed, who's applying a similar concept using complex system modeling, focusing on the management of environment and mangrove trees in Rio de Janeiro in Brazil. Of course, Rio is a beautiful city, and it involves lovely kinds of terrain, from forest to urban areas to coastlines. And one of the key areas that's still there is communities that depend on mangroves for fishing and for coastal health. Mangroves can play a key role actually to reduce erosion on coastal areas. And often communities who live near them may be at low income. And in this image, you're seeing a colleague, you're seeing Jack himself from Space Enabled, but also colleagues from the Federal University of Rio de Janeiro who've been studying the communities who live and depend on the mangroves to help support local fishing. And they're using a combination of satellite data and drones, as well as social science interview-based data to study the question of how to support the health of the mangroves and the communities. So here we're applying what I showed earlier, the environment, vulnerability, decision, and technology modeling to the particular case of the health of the mangrove community right there in Rio de Janeiro. And our colleague Jack is creating a tool It looks like this and is written in Portuguese, but it has the idea to show data from the environment, understanding the changing of the health of the trees, but also considering changes in things like local income and the ability for communities to be economically viable given changes in the local region. And there's also a question of how the government creates policies to protect certain forest areas and how it's enforced. So a lot of information is combined here, so people can ask, what has been the growth of the trees in the past? How are local economic outcomes for the people? And what kind of policies are the government using to help maintain and protect the forest, and are they working? So these kind of discussions are available, and you can learn more from our future publications. I want to pause there and actually stop the sharing and invite the discussion to start, because I think it's a great opportunity to ask, what are your questions about these topics, and how can we give more examples that are interesting for you all? So thank you so much. I'll turn it back to Hayley.
Okay, wow. Thank you so much, Danielle. That's some amazing examples there. I really like how you've shown like these big, broad concepts of like what it means to consider sustainability next to space technology, but then also these really clear examples of what that looks like on the ground in specific activities. I've really enjoyed that. We have got some questions coming through. The first one, which I think if I click this should show now. This one is from Isa Elegbede, and Isa, I hope I pronounced your name correctly. My apologies if I haven't. They'd like to ask about the sustainability aspect of space technology on humans. And the question is, do you think that issues of common resource pools could be possible in space? This is something I was thinking about too, and I'd like to add just a little bit extra to that question, if you don't mind, was that whether you thought there were other, I like the example you gave of air traffic control, but whether there were examples of these kind of, I guess like tragedy of the commons type management problems on Earth that you think might also be applicable in space. So yeah, two questions. Do you think that there'll be resource pool issues? Are there in fact already? And secondly, do you think there are analogies for how we might manage this?
So thank you so much, Hayley, and greetings to Isa. It's wonderful to have this discussion, partly because it's part of what I think is so powerful about the framework we brought today. We want to ask the question, what does it mean to be sustainable simultaneously in our oceans, on our land, in the atmosphere, in space, as in orbit around the Earth, but also wherever humans go. So I do want to emphasize the idea that I think we have often the same challenges, sometimes the same human behaviors in all those locations. What's powerful is that if you look historically, there's been a great tradition of international law and often treaty formation in each of these zones. I want to highlight the oceans themselves, as well as Antarctica, and then the atmosphere as kind of a global commons. So it's certainly true that in economics literature, there's a variety of examples of discussion around this idea of the tragedy of the commons. We can also look at work that further kind of asked, what are opportunities to avoid the tragedy, because people recognize that there's a need and there's a benefit to collaborating to address these kinds of challenges. So certainly it's very relevant that there's about 5 treaties that are the core corpus of space law. And those were developed by the committee that I showed the picture of, the Committee on Peaceful Use of Outer Space. So these are key space treaties. And we can compare them, for example, to the treaty that governs Antarctica, the treaties that cover the kind of interaction on the open oceans, on the high seas. So in that sense, we do have really parallel experiences in terms of international cooperation, often founded with the United Nations as kind of the core actor. And that means that states, like national organizations, are the ones kind of coming together to debate these questions of how should we create some guidelines and sometimes even formal, when we say international law, the international law is non-binding unless a country makes it binding locally. So when I say it's a law, if a country ratifies a treaty and adopts it as national law, it becomes binding in the sense that they enforce it nationally. And then if it's only adopted at the international level, it is really a very strong idea that everyone uses as a norm, but it isn't really enforceable in the same way unless you bring someone to international court. But even so, I think we've seen remarkable success in terms of international cooperation in Antarctica, for example. I think it's amazing that there are currently organizations, nationally driven organizations from countries like Chile, New Zealand, South Africa, that perform research regularly in Antarctica. And there's, for example, a US base for research there. And you see a lot of cooperation among different countries. For example, US researchers might travel to Antarctica through New Zealand, for example. So you do see this link where it's a place that's considered international location that no country sort of owns or takes over Antarctica, but yet there's ongoing interaction there. So we do definitely have examples that are very similar to space. You might imagine that in the future, there may be different bodies that have research stations on the moon, and they might look very similar to what we see in Antarctica, where there's cooperation to arrive there at this distant location, and there's perhaps cooperation and sharing of resources and sort of the ability to survive. But there's also sort of nationally driven or even national, but with private sector organizations, activity being done. So we do have this kind of experience, but I think we should even further ask if we see an increase in activity. For example, Antarctica, the number of humans that are there is relatively low, it's in the dozens each year. And I think we've maintained a safe level overall. We're not necessarily seeing large cities being set up there or major long-term activities that create a lot of pollution. So if people are proposing economic activity, for example, on the moon, that might be a different scale, and it might lead to a desire for larger activities. And I would like to argue that we should consider that very carefully. In low Earth orbit, for example, where we consider the altitude, say between 500 kilometers and 1,000 kilometers of altitude and orbit around the Earth, we already have a unique challenge, right? We have the challenge that there's a lot of people, a lot of companies who've announced they'd like to put a large number of satellites in that orbit, particularly for communication or Internet of Things or Earth observation applications. So we're at a point where we've seen an unprecedented number of satellites being proposed. And again, the scale might be something that we really should think about carefully. The number of satellites might be so much that it's different than what we've seen in the past. It might need a fresh kind of coordination, which is why we've argued for the need to talk about future space traffic management systems, because our traditional way of allowing everyone to kind of operate independently may not be adequate.
Yeah, I would fully agree. When you were talking about it earlier, it was reminding me of sort of some studies and information I've looked at with regards to fisheries management, which I think is, it's a very dense issue. It's something with a lot of people acting, a lot of people's backgrounds are and their economies are highly dependent on this, but it is in some cases this real open environment. And I think we could probably learn a lot from that sector as well. I'm sure you've looked at the interactions of space and fisheries as well. So yeah, that's one area that I would be really interested to see further work on. It's one area we've definitely not got it right yet either. So I think, the lessons are still really being learned. It's a very cutting edge kind of area. Okay, so next question we have here is from Elena Razzano, and she says, do you already have examples of applications developed to answer the COVID-19 health crisis? How much do you think the space sector will be affected by the effects of the pandemic?
Thank you so much for asking about our work on COVID-19. And what I'll do is I'll put in the link in a few moments. Basically, it's a link to the project page for our team. We are working on this project that I mentioned in the talk called the VITA Decision Support System Framework. And the link I'll share has a video that kind of highlights our progress so far. We've been fortunate to be able to collaborate with government leaders or university scholars in these various countries, including Brazil, Chile, Mexico, Indonesia, and Angola. And basically, it's work in progress. All of them are part of teams that are either part of the government itself or are informing government decision makers. And of course, from day to day, these teams have to just go forward with what they have. Whatever data they have so far, you try to figure out what are the right steps for the government to open or close businesses or provide social distancing guidelines or provide economic support. And I've been really impressed. The teams we're working with in these locations, they have quickly brought together local data sets that are really powerful to estimate what's happening in terms of the number of COVID cases, to estimate the expectation for if they'll be able to satisfy the COVID needs with the hospital beds that are available, and to try to be able to have a geographic sense of the spread of COVID. So what our team's been doing alongside is to figure out how to best combine data from a public health perspective with the environmental data, as well as socioeconomic data in a way that's more visually clear. So a decision maker might be asking themselves, should I move forward to the next phase of reopening? And they might be able to combine a concern with the public health aspects alongside how does this affect local economics. And we think it's most relevant at the scale of really a city or a region within a country, because often there can be quite different dynamics in one city versus another nearby city. And local people have the best sense of what's happening in the various neighborhoods, right, what's in their area. So we're interested in seeing how metropolitan city regions are making these responses and trying to collect data within their own areas. And so we've been very fortunate, and in a few minutes I'll add that link so you can see our results so far. We're looking forward over the next few months to continuing to expand this.
Yeah, I think with the pandemic situation is obviously incredibly sad for a lot of people at the moment, really difficult, but it is providing us with a really acute opportunity to look at many of these challenges that have these multiple aspects, an economic one, a health aspect, an environmental one, in a combined way. And space is somewhere I think that really comes to the fore. We can see so many different parts of these systems from space. And one thing I would recommend anybody who's listening, who's interested in this, to have a look at is our colleagues at the European Space Agency have been pulling together this dashboard with different examples of how space has observed COVID-related information. So that might be of interest to everybody as well. I think Sarah's just put the link in the panel as well. Thank you, Sarah. I can see you there. Okay, so
Yeah,
the
and I
next
added
question.
the link for our beta project. Sorry, the second link that I added is
That's
one you
okay.
should pay for. Thank you.
Perfect, lovely. I'm going to look forward to looking at that later. Okay, so next question comes from Greg Jenkins, who's asking about the dashboards that you showed and how these might be relevant in places like Africa that have maybe limited observations on the ground, and how these could help protect vulnerable populations and communities against natural hazards and future climate change. What are your thoughts on that?
Thank you very much for the question. I just want to respond also to what Hayley mentioned about the importance of the example of the fisheries community. I think it is a really powerful example. And it also reminds me of the importance, a lot of my work lately in the last couple of years, without really me planning, it linked to coastal and island nations, meaning coastal areas that are major cities that were often part of a colonial interaction between the local country and a foreign power. And they became major port cities. And now they're large economic centers and they have large populations. Or you can look at island nations where they are, of course, considering issues of the impact of sea level rise and erosion, but they're also looking at kind of their blue economy. They're depending heavily on the maritime economy. I have been interacting regularly with those from Indonesia, and they have major concerns in several parts of Indonesia with land subsidence, but they're, of course, also an island, a series of islands as a country, and so they're always considering the role of fisheries in their economy. So thinking about the question, first I'll highlight that I would actually say it's great news that we're seeing more and more examples of locally collected data across sectors. So I do agree that people have for many years said, well, there's not enough ground-based data from these countries, for example, in West Africa, to do validation. But I would say that that's no longer the assumption, meaning we might ask the question, who's taking the data and where is it? So I've been so excited. One example I've been pleased to see is several projects in air pollution and air quality data collection. And I mean, there's a few things that I can highlight, which US embassies, for example, try to, whenever they can, install a high quality air quality reference monitor from the BAM system. And they put the data immediately online as soon as they have it. So you can go online to EPA Air Now, and you can study whatever is available from US embassies that have excellent air quality sensors. But often local teams of university scholars have also put in low-cost data sensors that might be sometimes operating next door. So you can have a combination of the reference sensor with the low-cost one together, or operating in other regions around the city. Having one high-quality sensor is great, but having a whole network of smaller sensors is also really helpful. So I've seen great examples of this in parts of Indonesia, in places like South Africa, in parts of Kenya, in parts of Ghana. I'm just really impressed with both a combination of local teams and international teams collaborating with them have really increased the number of air quality data sets, for example. Also, I see a lot more teams looking at ways to use sort of moderately cost water quality sensors. Right now, for example, in our work in Ghana, we're seeing collaborative teams that are local government scientists with perhaps foreign partners. And there are data sets. Sometimes the challenge might be that those who collect the data know where it is and they have it, and maybe it's in a certain language, but it's not necessarily in other languages that might be relevant. And so the question can be like, are the data sets shared broadly enough? But I would say there's definitely data, and there's a combination of sort of in situ data from ground or water, plus aerial data, plus satellite data. So it's not that we have zero data, it's that we need to find the better ways to build relationships, sometimes translate things in different languages, and then make sure that there's data policies that do share it. And of course, then we should ask, what are the ways to ask permission and ask for advice from local communities, especially those that might be considered indigenous or that have lived in traditional styles that are not necessarily integrated with modern technology. One example I didn't show the slides for is from my colleague, Fatima Muniappa. She's originally from India, and she's a conservationist and a designer. Some of her work is focused on understanding the needs for data of indigenous communities that are forest dwelling and have for many years lived in traditional ways in forest. And they have unique ecological knowledge about their forest. And they know basically everything about the forest that nobody else knows. And so she partly is interested in conserving the knowledge they already have, but also asking them how they would like to collect data locally. She's creating a mobile app that will be a combination of collecting data through interviews and through photos, just of people telling stories and describing their knowledge, but also creates a way to geolocate data and information if they want to locally. But she's asking a community of people called the Khasi people in northeastern India, what they actually want in that tool. So we try to follow that model whenever we can.
Yeah, I really like this co-development model, like where you are, I think, I come much more from the perspective of kind of the satellite operations and algorithm development and things like that. But it's really hard to know what you're actually really looking for unless you speak to people on the ground and say, what is it you actually need? And what do you already know? And I think that can actually, from the side of the people who work in the sorts of sectors I do, can really open our minds to actually how we can use data that maybe we haven't thought about being there, but maybe just because it's not quite the type of data we're used to working with, and it can still be incredibly valuable. Like you say, because those people are on the ground and they know what's going on, they've probably known what's going on for a very long time. The volume of data that you get, which is absolutely crucial for things like algorithm development and product validation, is key. And that's a very, very rich source of it. So I really like this kind of co-development model. Okay, thank you very much. Thank you, and thank you, Greg, for your question. So the next question I have on my list here is from Stuart Bernard, who asks for your thoughts on the use of Earth observation for wealth creation. What do you think about things like disruptive market opportunities, with particular regard for community upliftment, knowledge exploitation, ownership? I guess this follows on a little bit from what we were just discussing.
Thank you so much for the question. It gives me an opportunity to highlight this past week. Another opportunity I had to share publicly was through a webinar series that my team's been hosting. It's called Serving Society with Space Data. And we've used the framework of the Sustainable Development Goals as an inspiration to bring together conversations like this. So this past Wednesday, we hosted an event talking about Sustainable Development Goal number 8. And number 8 stands for decent work and economic growth. And it includes several key targets. One of them highlights the idea of sustained and sustainable economic growth, the idea of sort of countries increasing economic progress, but also doing it in ways that try to reduce the strain on the environment, but also try to encourage fair work practices and sort of fair employment, including fair wages across different groups like women and men, but also people from different ability backgrounds, and also for youth. So some very concrete aspects of SDG 8 that speak to your question. Another piece addresses how there'll be growth of economic activity in innovative sectors, meaning bringing entrepreneurship or bringing new business models. So I'll put a link in as well in the chat, but we'll be posting the video. You can see a whole discussion for an hour and a half on how we explored several examples. We looked at examples from Benin, as I just showed, as well as from Chile. We also saw an international point of view saying, we do think that there are 3 ways that space technology, especially satellite Earth observation, positioning, and communication, do play a role already in SDG number 8. Number 1, of course, there's a question of partly just knowing what's going on. So sometimes you could use satellite data to estimate wealth and poverty geographically, the idea of looking at things like night lights or indicators of infrastructure and ask, can you measure where there's vulnerability economically? Step 1. Step 2 is, can you support innovative business models or innovative service delivery models by organizations? So I do think we see a number of activities. And in fact, one of my colleagues who's in my team is doing a research project estimating where there are new entrepreneurship models in Southern Africa, where she's from. And we're looking at examples that use satellite technology, but like in non-space businesses, like meaning in areas like agriculture and food security and responding to local water management issues, but they're creating new businesses that do take advantage of space infrastructure, but they're sort of, that's one of their side pieces. They're really focused on a different service delivery area. We're identifying that there's a new generation of entrepreneurs, actually all over Africa, for example, that are harnessing the latest information technology, a combination of mobile services as well as satellite data. The third piece then is to ask, can we evaluate the benefits of these technologies also using satellite data? Can we look back and see what's happened in the last few years to evaluate whether there's been progress, whether the business models are working, whether the government initiatives are working? So we think all 3 areas of what assessing the current state and enabling new business models as well as evaluating. So I'll put a link in for the video, and you can go back and look at our hour-and-a-half discussion on SDG 8 and satellite data.
That would be great. Thank you very much. Thank you. Our next question then, this one came through YouTube, so I'm not actually sure who it's from, but thank you very much for your question. They ask, when you're talking about space industry sustainability, are you framing this issue in the same way as the circular economy here on Earth?
Thanks so much for bringing up the term circular economy. It's a very useful term. And for those who are not familiar with it, I'll highlight this concept that could be described different ways, but one way to think about it is that if you have a circular economy, you try to eliminate waste as much as possible. And this would mean the idea that any sort of material that you're using, ideally is valuable material. You might use it for a certain product creation, but then when you're finished with that product, you don't consider it waste, you consider it the next generation of material. So I think we see this nice example, actually even from the case we showed in Benin, where they're harvesting the water hyacinth as a material product. They use it as a tool to clean up oil spills. And the next question is what to do with it next. You have now dirty water hyacinth with dirty oil in it. So one option is kind of destroy it by burning it, but they also want to find out, are there other ways to turn it into any kind of product that could be a next generation Can it be an input into another industrial process? This is an innovation question. So there's lots of areas, and actually you could sort of look at the SDGs again as this broader question of what's our global pattern of consumption and production. I think it's SDG number 12, if I remember correctly. And there's certainly this bigger issue that we as a society are very much used to like using materials and then turning them into waste and then trashing them. This is like a normal way of operating. So we do need to, as a society, rethink that. What are all the ways we can recycle and reuse materials? And we actually, in fact, we need academic research on this. We need novel examples, especially I think from island nations, which are used to the idea of conserving and sort of reusing materials as much as possible. So in space, you can draw from an interesting story, which is that when astronauts are living on the space station today, we have this collaboration of 5 parties in the ISS with the US and Europe and Japan and Russia and also Canada. You have the collaboration where currently astronauts do live in an almost closed environment where they have a certain amount of water and clean air that can be filtered and recycled and a certain amount of materials. And they do have something of a circular economy, meaning they reuse a lot of the water and the air is constantly filtered and recycled. And people who are inventing future systems for human spaceflight are trying to make it even more recyclable, like the air and the water, and even the ability to use waste to help create things like compost, for example. When people imagine living on the moon, they think you need to be more recyclable. So I do hope that the innovation from space spurs back to innovation on Earth, and the two sides can keep asking, how do we keep reducing waste more and more?
Yeah, I think that space society kind of innovation, like I've heard lots of examples of like sort of spin-offs and things, but I think this recycling and waste management has got to be a key one, right? Because I mean, just from a sort of economics of resource point of view, I mean, if we're going to go to Mars, we've got to take things there and that costs fuel and that potentially limits the mission, right? So we need to know how to optimize that. And I really think there's going to be a rich vein of things coming back that will support us here on Earth, which is great. Okay, so the next question actually also relates kind of to technology, but also society and public participation. This one is from Jose Garidi, who asks, we've seen how technology development influences societies and how they evolve, and at the same time, societies then influence and shape technological progress, creating these complex socio-technological systems. And then asks, how do you think that public participation processes could or should be incorporated into the development of new space technology and policies?
Thank you so much, and greetings to Jose. I can just acknowledge that I put a link in the chat just now for our event this past Wednesday, and Jose is one of our panel speakers, so really glad to have Jose on the call. He's from the Ministry of Science in Chile. And it's an excellent question. In fact, I can give you my dream answer, meaning if I had sort of infinite funds and time, I would love to organize a series of discussions, particularly with middle school children and high school children around the world, basically because I think people who are in middle school now will be voters in the next few decades, and they may play a key role as voters when it's really time to see the change of humans living perhaps maybe permanently in places like the moon and Mars eventually. So I want to kind of catch people young, but of course we want to talk to adults as well. But I'd love to hold a series of discussion processes, and actually there are groups that do something like this. The Space Generation Advisory Council brings together people from age 18 to 35, and they host events around the world which kind of highlight key space policy issues today and bring together recommendations from these organizations to the United Nations committee that I mentioned earlier. So this does happen. I think we could do it even at a larger scale and try to ask the question, what would these young people want to see if they were focused on sort of a global goal and they want to be sustainable both on Earth but also in space? And how would they propose some of the ways to design space societies? Meanwhile, one of our colleagues, David Colby-Reed, is doing research with our team at Space Enabled. He's taking an academic point of view on this. He's drawing from researchers and philosophers, scholars who think about issues of political theory and social theory. And he's developing a framework that will draw from a variety of research that will talk about the idea of enabling basically a democratic operations in space, meaning the question of how do you actually have a society where people from different backgrounds play a role in shaping the governance of society, especially if you think, traditionally we've had people go to space who worked directly for a government. They were government employees. So current astronauts are generally government employees or really rich people who paid to go, but most of they're government employees. In the future, if you have other people who aren't government employees also living and working in space, what will be their governance structure? How do they vote or how do they present their view on what's going on? Especially if the owner of the space base or vehicle, they basically control access to the technology that keeps you alive. So that's pretty important. So there needs to be a fair interaction. So we're studying this question from a theoretical point of view, but I think also it'd be lovely to do it from a sort of inclusive design process point of view and really ask people around the world, what would be the right way to create a new society? And I think we can also draw heavily because there are communities that have lived in harmony with nature through indigenous practices in many parts of the world, all over the Americas, parts of Africa and Asia, people from small island nations that actually do have traditions that have already demonstrated the ability to not overrun the environment with human waste. And they've shown a way to sort of really live in circular economies. We also should be drawing heavily from that knowledge and that wisdom while it's still available.
Thank you very much for that answer. I think it's really interesting. One thing that this kind of spurred me thinking about as well was, I presume you maybe feel this as well, that I feel quite strongly that we need to not necessarily justify, but that we owe it to the kind of public to let them know about, why we're investing money that we are in space. And I think, it's clear from the work you do, and I think, with the work that I'm doing as well, that we do this because there is benefit to be had on Earth from being in space, right? So my question is, what do you think we need to do as individuals who work across this kind of space? People who are operating satellites, people who are launching rocket missions, all the way through to, scientists using data. What should we be doing more to help the public understand why this is important and what the value is of it? How do you think we can communicate that better, maybe?
Thank you for this question. It's one that people often discuss. If you're working for a space agency, I used to work for NASA, there's an ongoing question of, do we need to present a justification for NASA's budget, for example? I like to give a few data points. One is that the NASA budget is about $20 billion per year, plus or minus, depending on the year. And people might look at that number and say, wow, 20 billion is a huge number. But they often don't look at it in context of the full US government budget, for example. It's less than it's less than 1% of the entire US government budget. So even if you look at the activities that the government of the US is doing, the amount that goes for our civil and research-oriented space activities is not so huge in context, but it is, of course, worth talking about. And it's very visible work. I can give an honest answer, partly saying that I get sad or sort of maybe tired sometimes of trying to say, well, it's hard for me to spend time telling people, oh, like it's important that we have satellites, for example. But I'd rather talk to them about how they care about knowing what their weather's going to be and having hurricane warnings. So I think people know they want hurricane warnings. And often we in the US are really happy to have the European examples of our hurricane estimates to figure out which part of the US will be in danger. So we are very thankful many times that we in the US can kind of turn to results coming from the European team, which, across the Atlantic, looking at the models. So I think if we talk to people about what they care about, like their safety in their homes, and they may understand that if you live on a coastline, they may be familiar with changes and sort of risk of flooding. If they're living in an area that has tornado risk or an area that has experienced fires, they do care about those topics. So I think rather than me telling them, I love building satellites, which I do, I should ask them, well, what are you worried about in your community? And if they have an answer that relates to the environment or relates to kind of public sector infrastructure, then I can try to explain and how my space-related technologies link to that if they're interested to hear it. But I think the goal is to talk about in the language of their interests and their needs. So I often teach my students a tool from system engineering called stakeholder analysis. And I always say, you're asking about these needs of these stakeholders, and the need has nothing to do with your technology. Like I have space technology, but their need is just what they actually need. It's nothing to do with me. And it will still be there when I'm done with my project, whether, that's really a function of who they are. So I try to start with that and maybe just use that language instead of my language if possible. I think translating between what I know about space technology and what they actually talk about in their communities is the key.
Yeah, I completely agree with you on that. I think that context you talk about is absolutely key. If you go in from the technology angle, like sometimes, people have an interest in that. Space is like, wow, rockets, that's cool. I think most people kind of get that. But if you come at it from the point of view of, your mobile phone technology or the local beach that you go to or the food that you eat, it's things that tangibly people understand. And I think, I like to try, and I think others can do this as well, to bring those conversations more to the fore. When you are talking about something that has a relevance with your people day to day, whether it's your family, your friends, members of the public, there's usually always a connection to be had to space, and I think it surprises people. So I think we can make the most of those opportunities. Okay, I think we're almost out of time, so I'm going to ask one more question, which summarizes a couple of questions that have been asked by people, and will probably be a nice one for you to finish on, Danielle, I think, which is a lot of people have asked, how can we be involved in this project, or how can we collaborate with you? So how does this work for you? What is the best way if somebody has a really cool idea based upon something that you've said today that they'd like to collaborate on? How do they get in touch with you, and where are you going next? What are your interests going forward?
Thank you so much. I appreciate you combining that. I noticed in the chat a few ideas of collaboration. I can give a few angles. I'd say it's in the very, very short term. Right now, our team is focusing on a few key projects, and I think we want to really dedicate our time to those projects and doing them very well. So I'd say like in the next 2 months or so, for example, we're not quite ready to start something new. I'm at a great season where I'm building my team, and I mentioned a couple of student names, and many people are kind of moving into their doctoral studies, and we're really excited about the project they have planned. I think in the longer term, of course, I hope that over the next few decades, I'll be doing this work, and it creates opportunities for connection. So I hope people can find me so on the website for Space Enabled, because I've added a few links for that. And I'm happy to sort of keep dialogue going. I will say that the projects that you see us reporting on now are all possible because local teams have proposed that we kind of work out something together. So I showed examples from West Africa, from Benin and Ghana. I mentioned work we're doing in India, as well as we have some work in Brazil. And I think we'll have other collaboration places like Indonesia in the future. So those are all possible because a local scientist or a researcher or a government team or company has identified a very concrete goal. And we saw that there was a clear way that like our skill set as an MIT team could link to their existing goal. We try not to create a brand new topic that is not locally relevant. We try to go with an existing topic that people already want to work on. So I'd say I don't have a big capacity now to start brand new things, but certainly what's been great for me is to be a part of a network of people that are already doing amazing work on the SDGs. If we stay in touch over time, there may be an opportunity in the future where there's either a proposal we can write together or a chance to kind of visit and collaborate. I will admit that 2020 has been tough. I used to travel a lot more to be able to get to know people in their own communities. And so lately it's been more virtual. So we are saving some CO2 into the atmosphere in that way. So lately I've been learning how to sort of do this kind of stakeholder engagement more virtually, and we're thankful for that as well.
Yeah, I think, and I mean, that's a really good note to end on, really, that these opportunities for collaboration, we're all working really hard to try and keep them going, I think, during this time. And, partly thanks to space that we're all able to do this. So I think we'll finish there. I would like to say thank you very much, Danielle, for talking with us today, for your presentation and for answering all the questions. And I'd like to say a big thank you to the Air Center as well for hosting us all. So thank you, everybody, for listening, and we'll see you again in the next weeks for more of these Networking Fridays.